Okay, good morning. Here's a video for our one eNotes talking about inverse functions here. So if a function is notated as f of x, okay, of the inverse is just notated f of negative 1x, okay, and that just means the inverse of f, okay, it's the inverse of f of x, okay, the inverse. Now, in practicality, inverse of a function is all you're doing is you're going to switch your x and your y values, okay, just switching the x and y values. Okay, so here um, we have our little blue function here, f of x, and we want to plot the inverse of f of x. Okay, we want to plot this inverse function right here. All right, so to plot this inverse function right here, I'm going to go over to Paint, and we're just going to flip the x and y values. So we're over here. I'll do this in red. Okay, so let's look at our graph here. Okay, our first point is going to be negative 8, 7. Okay, negative 8, 7. So we're going to flip them. So now we're going to go 7, negative 8. Our next point, negative 6, 4. So then we go 4, negative 6. Next point, negative 4, 4. So then we go to 4, negative 4. Just like that. Next point, negative 3, 0. So now we go to 0, negative 3. Our next point is 2, 1. So now we go to 1, 2. Okay. Our next point is 5, 6. So now we go to 6, 5. Right there. The last point is 8, 7. So then we go to 7, 8. Right there. Okay. So now all we're going to do is just connect the dots to get our inverse function here. Okay. So connecting these dots, follow along if you need to, just like that. So there you go. Okay. We have our blue function, which is f of x. Okay. And our red line, which we see is not a function here, vertical line test fails it. Okay. Is the inverse of that. Okay. Inverse of that. So looking at that design, okay, take some time, copy it down if you need to, do it on your sheet if you need to. Coming back to our notes here. So I want you to see if you notice anything about the function and its inverse, okay? What does it look like on a graph? So again, if we look at the graph right here, see if we can come up with some kind of thing that, we see from the picture there, what it kind of looks like. All right. Now, if we have an equation, same deal, okay? We just flip x and y. So here we have this f of x equals 4x minus 2. For this with inverses and stuff like that, I don't like using f of x. I'd rather just use y because it's just easier and it's just less dirty, I guess. Okay, so we have y equals 4x minus 2 is our original function. Okay, so the inverse of this function is x equals 4y minus 2. Okay, I don't know why that's there. Okay, so the inverse of that function is x equals 4y minus 2. What is really cool is that in the Desmos calculator, I didn't have this when I was young, you could type these functions in just like that. Okay, so if I were to go over to a Desmos calculator, Desmos graphing calculator right here, get this out of my way. So looking at this first function here, y equals 4x minus 2, which I think it is, like that. We can graph the inverse by just flipping x equals 4y minus x equals 4y minus 2. Okay, so the blue function is our original thing. The green line is our inverse. Okay, And again, looking at this graph here, we can kind of see some kind of relationship that they have here and what it kind of looks like visually if we can sort of visualize what they do to each other. Okay, what a function and an inverse do to each other. Okay, if we ever get to the point where we have to rewrite it in f of x form right there, what we would need to do is get y by itself. Okay, so we got to get the y by itself. So if we were to do that here, so if x equals 4y minus 2, okay, getting the y by itself, first of all, we'll add 2 and we'll add 2. All right, so then we have, I'm going to come down here, x plus 2 equals 4y. Okay, and we divide by 4. So the inverse function really is going to be, y equals x plus 2 all over 4 like that. Okay, it may, we may end up simplifying it more. It may kind of look, where we have y equals 1/4 x plus 2 over 4, which is 1/2. It could be written in decimal form. So we just need to be careful about how we solve this to get the y by itself. So, the inverse of this function, y equals 4x minus 2, if we were to put it in, y equals mx plus b form, okay, that would be, sort of our slope-intercept form right there, where it has, we have a slope of 1/4 and a y-intercept of 1/2. Okay, so slope of 1/4 and a y-intercept of 1/2. Okay, so what we can do is go ahead and find the inverse of each of these relations right here. So again, the inverse, all we're doing is swapping out x and y. Okay, so that should be pretty simple with these ordered pairs right there. Then I would like y'all to graph these functions here and then graph the inverse. If you want to use a Desmos calculator, go ahead. If you want to make a table of values, go ahead. If you can do it just doing y equals mx plus b, you can sort of do that as well. All right. Last part here, determine whether these functions are inverses of each other. Right, yes or no. Again, you can do that by swapping out x and y and seeing if they match up. If you don't want to do that, then you can graph them if you need to. Go in the Desmos calculator and see if they meet. So let's just say, for instance, we have, something like this. Let's say, example. Just an example I'm going to do off to the side here. So let's say we have f of x equals 4x. I don't want to do that. Let's say we have f of x is equal to x plus 4. Let's say we have g of x equals x minus 4. Okay, and we want to see if they're inverses of each other, right? So we know that the inverse is, x equals y minus 4, right? So we would write the inverse as x equals y minus 4. Okay, well, what we can do, if you want, is, okay, I have x equals y minus 4. Okay, and we also have g of x is equal to x minus, x minus 4 as well. Okay, so we can see if these two bad boys are inverses of each other. Okay, f of x equals x plus 4, g of x equals x minus 4. Okay, actually, this should be x equals y plus 4. Made a mistake right there. I'm sorry. Okay, so the inverse of this is x equals y plus 4. All right, and we'll see if it matches up with the g of x, which is, g of x equals x minus 4. Okay, so we don't really need to worry about our f of x right now. Let's just look at our inverse. Our inverse would be x equals y plus 4. So we go back here. So we have x equals y plus 4. There's our graph. Okay, that's our actual inverse. Our g of x, okay, is x minus 4. Okay, so we can just see if y equals x minus 4, and we see they're on top of each other. Okay, so we know that these two functions are inverses of each other. Let me do another example here real quick before I let you guys get after it here. Let's say we have another example. Let's say we have f of x equals 2x plus 5. Let's see, g of x equals 5x minus 2, right? Now, we want to find out, are these inverses? Okay, we know, the inverse would be, y, or check that, the inverse would be x equals 2y plus 5. Okay, if we were to just take this thing here and flip the x and y. So the inverse is 2y plus 5. Now we're checking to see if g of x is the inverse of f of x. Okay, so we can type in x equals 2y plus 5 here. That red line right there, that's our actual inverse. G of x is 5x minus 2. Okay, so let's see if we have y equals 5x minus 2. They're different. Okay, the red line is the actual inverse. The blue line is our g of x. Okay, so looking at this red line, okay, the red line is f of negative 1. Our blue line is g of x. They're not the same. Okay, so these would be not, this g of x would not be an inverse of f of x. Okay, so take a few minutes, try these out. Yes or no will suffice, and that is it for inverses, and we will talk about these a little bit more later. Thank you and have a good day.